Hello everyone, my name is Greg and today I prepared for you 5 questions from the latest meteorology exam in the last 30 days across all authorities. Topic for today, air masses and fronts. Question number 1. Please refer to the annex. Which cold front has the highest speed of displacement? And we have here 4 examples with different isobars spacing. So, whenever we want to roughly judge the speed of the wind and front movement, we have to check how tightly spaced are the isobars. The closer they are to each other, the bigger pressure gradient force and therefore the higher air mass movement speed. If you want to estimate the actual speed of the front, we can use the geostrophic wind scale, which you can find on the top left corner on the surface pressure charts. We have to just measure perpendicular distance between the isobars and read the wind speed for the spacing on the particular latitude. This last step is quite important because for the same spacing, the geostrophic wind will be weaker on the higher latitudes and stronger on the lower ones. As you can see on the provided image, the tightest isobars we can find in example number 2. Therefore, the correct answer will be answer number 4. And this one is correct. Question number 2. Where is the coldest air to be found in an occlusion with cold front characteristics? Ahead of the front, behind the front, at the junction of the occlusion, at the surface position of the front. Occlusion or occluded front forms when cold and warm front merge. It happens because the cold front travels faster than the warm front, undercuts the warm sector, and finally catches the latter one. We have 2 types of occlusions, cold occlusion and warm occlusion. Cold occlusion forms when the cold front undercuts the warm front. It happens when the cold polar air in front of the warm front is warmer than cold polar air behind the front. If the cold front meets the colder, denser air in front of warm front, then it slides over it along the warm front line, forming a warm occlusion. Since we are asking about the cold occlusion, therefore we'll find the coldest air behind the front. So answer number 2 will be correct. Question number 3. Occlusions are formed when a warm front crosses a mountain ridge, a cold front crosses a mountain ridge, warm front overtakes cold front, and cold fronts overtake warm fronts. So, occlusions is formed when the cold front catches the warm front. It happens because the cold front travels faster and eventually undercuts the warm front. When it happens, the entire warm sector is getting lifted above the surface, what creates a great amount of clouds and precipitation. In general, we can expect a mix of weather normally associated with the warm and cold front. Heavy periods of precipitation, a lot of convective activity, thunderstorms, wind shear, and so on and so on. And as a reminder, you have 2 types of occlusion, cold and warm. Cold occlusion forms when the cold front undercuts the warm front, with the cold polar air in front of the warm front, warmer the cold polar air behind the cold front. If the colder, denser air is in front of the warm front, then it slides over it, forming a warm occlusion. So, the correct answer is answer number 4. Occlusions are formed when cold fronts overtake warm fronts. And this answer is also correct. Question number 4. A non-occluded frontal wave passes the airport. What form of precipitation do you expect? Continuous rain or snow while the frontal wave passes for a period of some 24 hours, showers during a few hours until the warm front arrives, drizzle in the warm sector, continuous rain or snow on the passage of the cold front, rain or snow for about 12 hours until the warm front arrives. Within the warm sector, rainfall increases. On the arrival of the cold front, precipitation ceases. Or continuous rain or snow during several hours until the warm front arrives. The precipitation stops for several hours or becomes intermittent light within the warm sector. On the arrival of the cold front, showers will occur. Okay, so passage of the frontal depression is associated with a very specific pattern of precipitation. First, we should expect passage of a warm front. When the warm air is scrambling over the cold air, it forms a large area of stratiform clouds. Around 200 nautical miles before the front, the altostratus clouds are getting thick enough for rain to start falling, which continues subsequently from the nimbostratus clouds all the way to the front. In the warm sector, we may expect mostly low stratus, stratocumulus clouds in winter, or fair weather with some cumulus clouds in the summer. In any case, it will be associated with some light or intermittent precipitation. The cold front, due to the unstable characteristics, is associated with towering cumulus and cumulonimbus clouds. Therefore, we should expect thunderstorms and heavy showers during the passage. As you can see, this pattern is more or less described in answer number 4. Continuous rain or snow during several hours until the warm front arrives. The precipitation stops for several hours or becomes intermittent light within the warm sector. And on the arrival of the cold front, showers will occur. And answer number 4 is correct. Question number 5. Which type of air mass never occurs over Central Europe? Equatorial air, tropical air, polar air, or Arctic air? Let's talk first about what an air mass actually is. So, air mass is a large body of air which, in a horizontal plane, has almost uniform temperature, moisture characteristic, and very little pressure difference above the friction layer. The properties of air masses depends on the region of origin. For example, air mass which sources is a subtropical high pressure belt over the Atlantic Ocean will be moist and warm. In general, you have 4 types of air masses: equatorial, tropical, polar, and Arctic or Antarctic, depending on which hemisphere we're talking about. As you can see, the classification indicates the region of origin. For example, the most common air masses over the Central Europe, the polar maritime and polar continental, have their sources in the North Atlantic and Siberia regions respectively. And tropical maritime and tropical continental have their sources over a subtropical pressure belt over the Atlantic, especially in Azores High, and over North Africa or Southern Europe. In winter, you can also expect a very cold and saturated Arctic air mass, which can bring cumuliform clouds with snow showers. Now, regarding the equatorial air mass, this is the one that we would never encounter in Central Europe. Even in the summer, the heat equator, together with intertropical convergence zone, the ITCZ, and the equatorial low pressure belt, won't reach higher latitudes than Sahara region in North Africa and maybe 45 degrees latitude in the Southern Asia regions. It's connected with global air circulation and the structure of Hadley and the Ferrel cells, and the subtropical highs belt between them, blocking the passage of the equatorial air mass to the Europe. So, the correct answer will be answer number 1. The equatorial air mass will never occur over Central Europe. And this answer is also correct. Alright guys, thank you very much. That's all for today. I hope you enjoy and see you next time.